Okay, this video is for 11.4G, exterior angles and diagonals. Alright, let's skip the first section and go down to the second section. It says, find the measure of each exterior angle in the following regular polygons. Well, in a regular polygon, every single exterior angle, when added together, they have to equal 360 degrees. So that means that since they all have to add up to 360 degrees, if we just divide by how many sides the shape has, it will tell us the measure of each exterior angle. So 360 degrees, and a hexagon has 6 sides. So we divide that by 6, we get 60. So each exterior angle has a degree measure of 60 in a hexagon. 60 degrees. Alright. Now, given the measure of each exterior angle, find what kind of polygon it is. So the same idea is true as the last section, but just backwards kind of. So all angles add together have to equal 360 degrees. So if we divide by the angle measure, it'll tell us how many sides in the polygon there are. So 360 degrees divided by 45 degrees tells us that there are 8 sides in this polygon, which is an octagon. So in an octagon, what this means is every single external angle measures 45 degrees. Now, let's take a look at the bottom section. Find out how many diagonals can be drawn. So that's going to deal with how many sides there are as well. And in a nonagon, there are 9 sides. And there's a formula we talked about in the notes, and we can apply it here. And that formula is n times n minus 3 divided by 2. This formula will tell us how many diagonals a shape has, and n stands for the number of sides. So we have to just plug in 9 into those two n's. So that's 9 times 9 minus 3 divided by 2. Well, 9 minus 3 is 6, so the top becomes 9 times 6. We've got to divide by 2. 9 times 6 is 54. And then 54 divided by 2 is 27. So in a nonagon, 27 diagonals can be drawn. Alright, let's move to the back. Find the value of x, it says in 16. Well, we know from our discussion on this page and from the homework that all the exterior angles have to add up to 360 degrees. And you can see that there is an x in every single one of the exterior angles in this polygon. So if we add them all together, set it equal to 360, we can solve for x. So x plus 2x plus 2x plus 4x plus 3x has to equal 360. So let's combine our like terms on the left. 1x plus 2x is 3x, plus 2x is 5x, plus 4x is 9x, plus 3x is 12x. So all those terms simplify to just 12x. Then it's just one step from there. Divide both sides by 12. And we get x equals 30. All right. Let's do 2 more. First, they want us to draw all the diagonals and use the formula to prove our answer. So if we look at a point in a triangle and we want to draw a diagonal which cuts from one point to another, but it is not a side, you can see that we can't do that. If we were to connect 2 angles from any of these angles, it would actually be a side, right? And that's no good. That's not what a diagonal is. So we would say this has 0 diagonals. Now, let's use the formula to prove our answer. Our formula, again, was n times n minus 3 divided by 2. Well, this is a triangle, so there are 3 sides, so n is 3. So 3 times 3 minus 3 divided by 2. Well, 3 minus 3 is 0, so the top is 3 times 0 divided by 2. 3 times 0 is 0, and 0 divided by 2 is 0. So that checks out. Alright, let's draw them in 21. This has 5 sides. So a diagonal looks like this. If we're going to start from this point, we can draw one to there, and we can draw one to there. We can't draw it to the other 2 sides because our diagonal would be our side, and again, that doesn't count. So let's move to this point then. So right now we have two diagonals. 3, 4. This one to here has already been drawn, so we can't count that again. There's a new one though. So that's 5. And we've already drawn 2 from this point. We've already drawn our 2 from that point. So we would say that this shape has 1, 2, 3, 4, 5 diagonals. Let's check it. So this shape has 5 sides, so n equals 5. 5 times 5 minus 3 divided by 2. 5 minus 3 is 2, so the top is 5 times 2 divided by 2. 5 times 2 is 10, and 10 divided by 2 is 5. So this checks out. 5 diagonals is what we get from the formula. 5 is what we showed in the shape.